Welcome to another video. So in the previous video we saw the Robo Dog Mini individual leg or individual servo motor, how it was moving, and we got a full understanding about the servo motors, their range and how they are mirrored from left to right. And now in this video we will try to move the Quarky dog or let him do some gestures. So let's plan something and do it. So let's start with simple thing. So we have this map with us, right? So don't lose this map because this is going to help you a lot when you are trying to prototype in a speed manner. I mean, when you want to do some complex movement, if it is handy, you can quickly type those things in your PictoBlox block, and then it will be working in the first shot. Okay, so let's keep it as a bible or okay. So now what action should I perform? So what I am thinking, I want to let me think. Okay, so I want him to move front, or it will move front and I will see, but at least I want to do something like this. These are the 4 legs, right? 4 legs. I want, or I can show it here. So I want these 2 legs will move little bit front, while these 2 legs will move little bit back, and in the next step this guy will move back and he will move front. So for that, first of all, we need to move all of them together, right? So how can we move all of them together? Let's see. So first of all, so this was the code earlier. What I will do is, now we will set everything to its neutral position, which is the 90 degree, right? So for that, we'll move from servo motor 1, we'll make it 90, move. Okay, so all 4, 1, 2, 3 and 4. Now instead of, I can directly attach this because this is the initial position where on click of green flag it will do. But to make it more manageable, maintainable, or a good programming practice, I would say, let's create your own block. So this is the opportunity you should use to write a good code. So what I will say, neutral. Okay, neutral pose. Okay, this is the name of the function, and what it will take as a parameter, nothing, because neutral means we know all the legs and their positions. So we'll just say neutral pose, and it created a user defined function for me called neutral pose, and I attach it to that. And how to call it here? By calling this block. So once you click this, this will get called. So nice. Now on click of this green flag, just notice what happens. Okay, so it came up, but have you noticed they were not in a sync? Let's find it out, okay, over the time. So now 1 2 3 4, they all are done. So now it is neutral pose. Now what I want front, okay, left side to move front and right side to move back. That means I have to refer back to my old pose, and I will connect it here. But okay, before that, let me find out what are the values. Okay, this is the state 1. So this is the state kind of thing. What we have to do is, initially, so let's draw some state diagram. What is state diagram? So now we know our dog, to move, it have to follow some steps. Like what happens when you walk? We walk, first we move our leg up, then we proceed it in the front, then the back side leg comes up, and it proceeds from. So this all step, like move your leg front, is step 1. Then it put the leg in the ground, and then the back leg will come up. Maybe these two happening at the same time. This leg falling down and this leg about to go up, and then it's go this leg, the back leg also will go front. So these are the individual step or states. So we have to first define the states. Okay, so state 1 S1, sorry, pen. State 1 is all the leg are in 90 degree. So let me draw like this schematic diagram. State 2, I want this 2 leg to be front and this 2 leg to be back. And state 3, this 2 leg front and this 2 leg back. For state 1, the positions are 90, 90, 90, 90. That we have already created our own function. Now what about this step? So just imagine, just assume we have selected 30 degree. Okay, so 30 degree and 30 degree. So these two are 30 degree front. 30 degree front in the sense you have to go for this side, you have to go backward, means 90 minus 30, 90 minus 30, how much it is? It is 60 degree, right? So you have to mention for this guy S1, S2. Okay, state and servo both are S, so I'll make it ST1, ST2, ST3. Okay, and this is the servo. Okay, so for here S1, S2, S3, S4, S4. For state 1, all are 90. For state 2, I decided to be 60 degree. You can choose your own angle. To see, you have to see the mechanics, I mean the balance, center of mass and all these things. How much the Quarky can balance when you position your servo motor in this state. Okay, so what will be the angle? For S1 and S3 is going to be the same. They are a pair. And S2 and S4 are the pair. So the S1 and S3 will move in one side and S2 and S4 will be the opposite. That's the mirror thing, right? So S1 and S3, if I want to move to the state 2, S1 and S3, they will go backward, means towards the 0 degree. Towards the 0 degree means if I make it 30 degree and then it is in 90 degree and it will move 30 degree this side, means towards 0, means 90 minus 30, this is 60, right? So S1 and S3 will be 60 degree, and S2 and S4 they are going other side, right? And which is again the same. So this guy is going towards this, which is again 90 degree towards 0 degree. So he is also 60 degree. But they are mirror, right? But how all the degrees are matching? Because they are doing a mirror act. I mean the legs are mirroring itself. So your values are same. Yeah, if I hope you understand. I don't want to explain more on that. Now the question is how to move the other side. So now other side, when you move, you are actually adding on the top of 90 degree. So the same 30 degree you are adding on 90 degree. So it is 90 plus 30, 120 degree. So this is 120, and obviously all will be 120. 120. Okay, so let's try this. So 90, 90, 90, 60, 60, 60, 120, 120. So now let's try 60 and we'll name it move front, and state 2, which is move front, and state 3 is move back, or I'll name it state 2 and state 3. Okay, you understand what it means. So 60 is state 2. So now I'll create one more block. We'll name it state 2, and I will mention what is that movement I want. Walk. So this is the state 2 of walk, so that in next gesture or in next movement, when I give it a name, there will be a state 2 for the next movement also. Maybe it's running or doing some cute poses. For that I will use the same state 2, but it will be walk. Instead of walk it will be something else, cute pose or something. So state 2 walk and state 3 walk. So this 2, and let's define them. So 2 is 60 degree, right? So I'll just copy paste and stick it here, and then make this all 60. Okay, so now let's move it. State 2 and state 3 have to repeat itself. Do we need the null in the middle? I mean, I think it's okay. And then we have to keep repeating. That means we need a repeat block, and so that it doesn't go out of my webcam, I will repeat only say 4 times, and then I will add this. We'll give a delay in the middle, and let the delay be 400 millisecond. We'll duplicate twice, state 2, state 3, and done. So now hope you understood, and now let's see how it works. I will click on the green flag. He is ready in 90 degree, and now I click on the space. I want to show you one more time so that you can appreciate if the servos are moving the way we want. And because I'm holding in hand, I will make the repeat 10 times so that I can show all the side. So this side, you see, this is the better side. But you see one thing, as I was telling you to notice, this two leg, repeat, tilt it. This 2 leg or the other 2 leg, they are not moving at the same time. So you notice, I will play one more time. You notice this leg might move fast, and then this leg will move. There will be slight delay between these two movement. Let's see. Sorry, I have to first click on the flag. It will initialize the Quarky expansion board. See, that's very important. You cannot do shortcut. Now you notice the legs are not moving at the same time. What can we do for that? It's moving, but not the way we move. Actually, we don't have 4 legs, but if imagine you have 4 legs, how you would move, it's not the same. Or look at a dog. So how can we do that? For that, what can we do? We can, that means we want both the leg to be executed at the same time. We need to run all of them at the same time. And how can we do that? Just pause the video and think for a while, and let me do that. So what I will do is, I will send a broadcast message, okay, and I'll create a new message called st3 state 3, and it will essentially do the same thing. It will move all of them, but we'll go to this. When I receive broadcast message st3, I'll just move it aside. Actually, I should do for all of them, but let's get an example. I will give an example only with one thing. So this take an example for this state 3, and what I will do is, I'll repeat it 4 times. Okay, repeat it 4 times, and now I will connect with each of them. So what I am essentially doing is, I am executing all the servo at the same time. And just make a note, or be careful, you should not do this with same servo number. If suppose, what will happen if servo 1 and this is also servo 1, and you are sending a broadcast message, and the same servo 1 is getting message of 2 different angle. In this case they both are same, but imagine if they are 2 different angle, then same hardware you are commanding to move at the same time simultaneously at 60 degree, and suppose this is say 90 degree, for example, for some other movement. So you are telling one hardware to move 2 different location at the same time. It cannot happen, right? It's physically you cannot be in two different places until you are a quantum particle, right? So this it cannot happen, and it is I think the PictoBlox will pick any one of them, and immediately it will pick the next, and you might get a jerk in your servo motor. He may not get enough time to react, and the final effect may not be what you expect, or it can damage the servo motor probably. So yeah, don't do that. Just ensure that whatever you're running in parallel, they should send message to different servos, not the same servo. Okay, so with that, okay, it makes sense that I should do it for the state 2, otherwise I cannot show you that it's really working. So okay, so this is what, and ideally I should do this, but I'm just skipping it because in this sequence of action I don't have the neutral pose. Okay, so now let me click on the green flag. He's ready, and for the 10th time I will do, because I want to show you, or I want to also see that is it really working, because I'm doing it the first time. I hope it should work. Let's press the space button. Oh no, it's not. Only one leg moved, but we programmed state 2 and state 3, and looks like only one servo can move at a time in parallel. They don't move all at the same time. So this idea is flopped. What can we do for this now? Do you think there is a magic block that can help us to do this without doing all this circus? Along with that, I will add on more puzzle and solve both at the same time. The other puzzle is, you see the change is very subtle. I mean, very it's suddenly changing. Like you're in the 90 degree and immediately you're moving to 60 degree. It would be nice if you move from 90 to 91, 92, 90, I mean the back way, 90, 89, 88, like that till the 60 degree. You can get the smooth transition instead of sudden jerk, tank, like that, like a robot dog. He's a robot dog, but make him feel like a natural human, I mean the organic dog, right? So how can you do that? So these two problems at the same time. So how can you do that? If I explain that, you should first know what is your initial angle, and then you should know what is the target angle, and then you have to run a repeat block, and the repeat, how many times it will repeat? Let's come back to our rough note. So suppose this is your initial angle and you want to move to this angle. This is 90 degree, and let me use my mouse pad. Okay, yeah, and then this is the 60 degree, and you are moving from 90 to 60. So now what we will do is, your first step will be 90, or 90 is already there. Next will be 90 minus 1, then minus 2, minus 3, like that till 60. So how many steps? 90 minus 60, total 30 steps. So you have to run a for loop or any loop for how many times? 30 times, right? Or if you want little more jerk, because it's very slow, it will be very slow, so you can make it minus 2, minus 4, minus 6, little bigger jump. Then this 30 will be divided by 2, means in 15 step you can complete the transition. But what is the gain? By this you can make the transition more smoother. So this is the other achievement. So how can we achieve both of them, knowing that this broadcast parallel way is not working? For that, they have created a new block. I believe that this is the reason they might have created. They realized this is really going to help us to concentrate more on the logic and less on the internal details. So let's take this. You see, all the servo, you're just telling where to move, and internally it will take care of all the transitions, all the parallel movement. Or is it? Let's see. Okay, so now it's the same repeat block, same state work. and what I want is all of them to be state 2 all of them to be 60 degree. So you see lots of servo motors. So this many servo motors you have in your expansion board, but you are not using all of them. So for me, S1, S2, S3, S4 I'm using. If you are following the layout diagram of Stempedia website, then for you it will be S1, S2 and probably S5, S6. So you can just change this also. So no harm for me, I can change all of them. And because nothing is connected on this other panel, it's okay. And this is the transition time. So you say whatever movement I have given from initial to this target position, you finish it in this much millisecond. So it's an extra thing you are adding into this equation. Not only you are telling this -2 -4, you are telling the time delay in middle of these two, because you have to divide that 1 second or 100 millisecond that you provided into this many pieces, and that you have to insert the delay in middle of this movement, right? That's how you are going to achieve. So they have done all this thing. You don't have to think about it. Just have the understanding clear. It will help you in future to make your own complex movements, right? So this is like that. I'll not go with, okay, let me do it for the sanity. Okay, done. So in 1 second, I don't want it to be 1 second. Let it finish in 500 millisecond, and that's all. Let me try. So click on the space. Now see, do you see they all are moving at the same time? So simultaneously they all are moving, and that's the effect we want, right? Nice, good job Stempedia. You found the pain point and implemented at the right time to make our RoboDog experience butter like, right? Yeah. So yeah, so this is the simple walk, and you see it's moving to some extent but not very nicely. What I would suggest is you should have more friction here. So I would suggest you can add some rubber band or some rubber pad in this tip, in all the 4 tip, so that it can get a better grip, or make this floor rubbery, or you should have a friction between them so that it can move forward faster. Okay, so with that, where I am, I'm here. With that, let me close the video, and maybe the next video I can think of some better complex movement, where instead of having this state 1, state 2 and state 3, we can have multiple states. And also we can think about how can we generalize and share a SB3 file where you can punch in your value and get any complex movement without touching the boilerplate code. What is the boilerplate code? If you touch this data, right, I mean if you touch this state 3 and state 2, they are too much of internal details. When you want to really work with the RoboDog movement, you don't want to bother about these small details. You have to abstract them, and this nitty-gritty internal details are called boilerplate code. So we don't want to see it. Once we write it, we don't want to see it, but it should be there somewhere, and just we should come up with some proper naming. And how can we devise that? Please come up with your own idea. Write down in the comment how can we better modularize the code and distribute to the community. Okay, that's a nice exercise. Please call me, WhatsApp me if you need some help how to better organize your code, and that will be a skill for future. You will be one step ahead of others who just make the Quarky work, but the code looks messy. For your code will look cleaner. You will be one step ahead of them. So nice, good idea. Thank you so much for watching my video. Bye bye.